Hi, this is Chris. We are in SAT, Digital SAT Test 1, Math Module 2. This is going to be the easier math module. So this is the one that comes up if you just skip past the first module. So there is a harder module. We will do the explanations for those questions as well. But for now, we're on question 15, and let's take a look. It says an object travels at a constant speed of 12 centimeters per second. At this speed, what is the time in seconds that it would take for the object to travel 108 centimeters? So this is going to be a distance, rate, time question, and the formula is that your distance will equal your rate times your time. So when we say rate, that's what we're talking about is the speed. The distance here is 108 centimeters, so we're going to plug in 108 for the distance, 12 for the rate, and we're going to solve for t. We do 108 divided by 12, and we get 9 is our result for t. If you need to do calculator to help you out with that calculation, no worries at all. Definitely important to make sure we get it right. All right, let's take a look at 16. John paid a total of $165 for a microscope, which in my experience is not too bad, actually. That's a pretty good deal on a microscope. By making a down payment of $37 plus P monthly payments of $16 each, keyword there. So to get that total of $165, and we can see all of our answer choices have that same setup where we're trying to see what equals $165. We have a $37 down payment, and then we have plus P monthly payments of $16 each. The each lets us know that that's going to be whatever that monthly payment is times the number of payments. That would be 16p. And then just be careful here, because just to trip us up a tiny bit, they describe it in this order, 37 plus p times 16. So they put the 37 first, but the way we see the correct answer written, our correct answer is C. They switch it up on us. This is 16p plus 37, so just make sure you're clear about which one represents the down payment and which one represents those monthly payments that are going to be the 16 each, because you don't want to attach t to the wrong number. A lot of people on this visually might see this and then gravitate towards d, so just make sure we're very careful there. And now we can move on to 17. Here we have an xy table, and it says the table shows 3 values of x and their corresponding values of y. There is a linear relationship between x and y. Which of the following equations represents this relationship? So whenever you see a question that's set up this way, our first instinct should be to take these corresponding values, these pairs, these coordinate pairs for x and y, and try plugging those in to your answer choices. So you could try to create this equation on your own and figure out what this means in terms of slope and do a few different more sophisticated calculations, but it's going to be really straightforward and fast. If we plug in a 0 for x, we should get 18 for y. All right, let's see. So when x is 0, let's see how we do with these answer choices. Here, if I plug in a 0 for x, I get y equals 13. Well, that's not correct. It was supposed to be 18. When I plug in 0 for x and b, I get 18 for y. That's okay. That one checks out. If I plug in 0 for x on C, I get another 13 there. That's not it. If I plug in 0 for x on D, I get 18 again there. So I've already eliminated 2 answer choices, and the math that we had to do wasn't that difficult, hopefully, by plugging in a 0 for x. Now let's try another pair, because oftentimes you will end up with more than one answer choice that works after the first pair that you test. So let's try one more. Here, we're going to try our next pair. We're going to do x is 1, and we should get 13 for y. And anything that we've already eliminated, we can ignore. So you don't have to worry about A and C. Just look at B and D. When I plug in a 1 for x on B, I get 36 for y. That's not what was supposed to happen. I was supposed to get 13, according to this pair. So it's not that one. It must be D. Let's just double check real quick. If I plug in a 1 for x, I get negative 5 plus 18. Hey, what do you know? That one's 13. That one checks out. That one's our correct answer. So rather than trying to solve for slope or create your own equation of a line, which is certainly great if that's something that you can do comfortably, but here it's going to be a little bit easier for us to tackle this by just looking at the values in the table and taking those corresponding pairs for x and y and plug them in to see which equations work. All right, let's try 18. This one's a little bit longer. It says an object is kicked from a platform. The equation h equals negative 4.9 t squared plus 7t plus 9 represents this situation, where h is the height. All right, helpful to know. Of the object above the ground, in meters, t seconds after it is kicked, which number represents the height in meters from which the object was kicked? Well, when you're kicking the object, that instant, that very specific moment, right? So we're on some sort of platform here, and we're kicking an object. So let's make it a ball. We're going to kick this object off the platform, and it's, going to travel along some sort of path. So here, that moment that you kick the ball, what's the value of time at that moment? And hopefully we can appreciate that where we are starting from, anytime you're looking for initial value or starting value, that's really like saying that your time is 0. So this is just a creative way in the text of this question for them to let us know that the time is 0. And when we plug in a 0 for t, we can essentially cancel out these two terms. So our height initially is going to be 9. So right here, this is going to be a height of 9 right here, right at the top of our platform, the moment that we kick that object. And that's going to be answer choice D for number 18. All right, let's take a look at question 19 here. It says, which table gives us 3 values of x and their corresponding values of h of x for the given function h? Well, hey, we just did something kind of similar, right? They gave us the table, and they were asking for the appropriate equation. Now they're giving us an equation. Let's see if that works for these values in our table. So just go ahead and work on these sets of values. Plug in one pair at a time. Here for A, if I plug in a 1 for x, do I get 4 as my result? Well, let's see. That would be 1 squared minus 3. That would be 1 minus 3, which is negative 2. That's not 4, which means A doesn't work. And you could pick any pair that you want. So sometimes it's easiest just to go with the first pair. But if you're not comfortable working with certain types of numbers, so on this one, for example, if you don't like negatives, that's okay. You can try picking a different pair and see what works. You might end up having to pick more than one pair, so just be prepared to work with any kind of number. But if we want to gravitate towards something that we find easier for ourselves, that's perfectly okay. Let's try this second pair here. If we did a 2 for x, that would be 2 squared minus 3. So that's 4 minus 3, which is 1. Hey, that checks out. So that's okay. We keep B on the table. It does not mean you pick answer choice B, because there might be other values in the table that don't work. But for now, we keep it on the table. Let's try answer choice C. Well, we already know that 2 and 1 would work. So we don't need to really repeat that pair, because that wouldn't help us clarify anything. So let's try maybe a different set where the numbers change a little bit. We can pick anything we want. Again, if we want to shy away from negatives, that's okay. Maybe here we want to try this pair when x is 3 and h of x should come out to be 3. Let's see. This would be 3 squared minus 3. Remember, we're just taking whatever values here. Let me highlight these. But we're plugging in these corresponding x values into the x in the equation above, and we're trying to see if we get the correct value that matches in the table for h of x. So 3 squared minus 3 would be 9 minus 3, which is 6. So let's see, did that give us a value of 6 for h of x to pair with that 3? No, it didn't. So we can eliminate C. All right, and then, hey, look at this. Let's see if we can use a little strategy here. I already did the work to say that this pair of 3 and 3 is a no-go, right? So if that's a no-go here in answer choice C, guess what? That's going to be a no-go for answer choice D as well, because the same thing would happen. I'd plug it in, 3 squared minus 3, I'd subtract. I'd get the same result of 6, which does not match what they have in the table. They have a value of 3 for h of x, which means that's an incorrect value. We can eliminate D without having to do that extra work if we recognize that it's the same pair being tested there. And we're good to go with answer choice B. And we lucked out here because we didn't have to mess with any of those negatives. So sometimes gravitating towards those easier values first maybe means that your overall math that you're going to have to do, even on a relatively complex question, might be simplified just a little bit, which can save a little bit of time, a little bit of stress, and hopefully allow us to get a correct answer on test day. All right, stay tuned because we're going to dive into question